Good morning, class. Today's lesson is going to be on the colligative properties of solutions. For those of you who like to plan, we have one more lesson after this one, and then we'll take our assessment. That'll be next week. So today we're talking about the colligative properties of solutions. We know what a solution is. We know how to classify it. We know how it happens. So now we're going to take a look at when you add something to a solution, how the properties overall are going to change. And that's what the fancy word colligative actually means. A colligative property for us is the property of a solution that depends on the amount of solute dissolved. Remember that in a solution, the solute gets dissolved, usually it's a solid, and it gets dissolved by the solvent. And in most cases for us, that's going to be a liquid. So when the solute dissolves, the overall property of the solution is going to change. Now, why does this happen? When the solute dissolves, it creates ions. When these ions go into solution, it affects the overall property. And I'll diagram that out for you in a few minutes. The reason why this happens, when those ions go into the water, they interrupt the attractive forces that are occurring between the water molecules. You should remember that in water, water is a polar molecule made up of one oxygen and two hydrogens. Notice that in this slide, I see 5 waters, and the waters are aligning themselves so that the negative O can attract the positive H. When this occurs, we get this attractive force. That's what holds water together. Well, when I'm trying to boil water or freeze water, I have to overcome these forces of attraction. When we take a salt or solute and dissolve it in water, things change. So on this slide, we see that NaCl is now being placed into the water. And look what happens. The Na and the Cl are going to separate, they're going to ionize, and they're going to attract themselves to the different parts of the water that causes the attraction. So notice Na being positive attracts to the O, which is negative, and the Cl that is negative attracts to the H that is positive. So when I add a solute in water and it dissolves, now I get bigger molecules. So to get this solution to boil or to freeze, I not only have to overcome the forces between the water molecules, now I have to overcome those same forces between the molecules and the forces between the ions that are now attached to the polar molecule of water. Because it takes longer for this to occur, I get a change in the freezing and the boiling point. Now, when we're talking about colligative properties, there are only 2 that we have to worry about. There are a few others, but the 2 main ones for us are freezing point depression and boiling point elevation. And the great thing about these 2 colligative properties is that when we're talking about freezing point depression, the words freezing point depression tell you what's happening. If I take a solute and it dissolves in water, the freezing point depression goes down. So as the amount of solute dissolves increases, my freezing point decreases. Freezing point depression. Pretty easy to understand, but we also need to know how to pick it out in a particular question. The other colligative property that we need to know is boiling point elevation. Again, the 3 words boiling point elevation tell you exactly what is going to happen. As the amount of solute dissolves increases, the boiling point increases. Notice elevation means goes up, increases means goes up. So it's easy to identify. This is why, if we put an analogy to what happens in the real world, when it snows, when it ices, we put salt on the roads to melt the ice. Now, why does that happen? If you think about it, it's pretty simple. Snow, ice, freezing rain, all it is water that's cold. Well, the only way to get ice, snow, or freezing rain to melt would be to change the air temperature, which we can't do, change the ground temperature, which we can't do, or chemically change what actually lands on the ground. And that we can do. If we put salt on the road, when the water or snow, ice, sleet hits the salt, it becomes salt water. And because salt water does not freeze at 0 degrees Celsius, it begins to melt. Genius. Those of you who cook, boiling point elevation. If I have a pot of boiling water and then I add salt to it, like magic, the water stops boiling. That's because now, once you add the salt, it becomes not just water, it is now salt water. And all of those extra intermolecular forces of attraction must need to be overcome before the water reboils. Okay, so there are definite connections to everyday life, but we want to see it in the chemistry perspective of reactions and formulas. So let's take a look at these ideas. When we're talking about a solute, we have to also connect our bonding information because solutes are ionic salts. So ionic solutes are going to lower the freezing point and raise the boiling point more dramatically. So I have to know from bonding what makes something ionic. And we've done this plenty of times throughout the course of the year, but we'll review it once again. Remember, when something is ionic, it has to be made up of a metal and a nonmetal. So that's a positive and a negative coming together. So in these problems, when they're asking you about a colligative property, as soon as I see a metal, I know something's ionic. So sometimes the questions are very simple. If I know which is the one that's ionic, it's easy to pick out. However, they also tie in the mole connection. Remember, mole connection, moles represent number of molecules, number of things going in. So in these problems, we also have to worry about the amount. As the substance makes more ions, it's going to lower the freezing point and boiling point more dramatically. So here, a lot of times in these questions, you're going to be given 3 ionic solutions, and you have to pick out the one that's going to be the lowest freezing point or the highest boiling point. For us, that means counting the number of ions. So you have to remember that when you look at a formula, how to get the ions that exist. That's from formulas. Let's take a look and remember that as well. When we look at NaCl, notice that Na and Cl is 2 ions. Pretty easy. There's one Na and there's one Cl, which makes 2 ions. Barium nitrate is BaNO3 too. Well, here I get 3 ions. The reason why, the formula has 1 Ba, but it has 2 NO3s. That's barium nitrate, 3 ions. The last example that I gave you was aluminum oxide. Aluminum oxide, Al2O3, notice is going to have 5 ions. That's because there's 2 Als and there's 3 Os. Now, I left out the charges here because all we're counting really is the formula units to get to the correct answer. You would want to make sure you put ions in there if you are writing out these reactions. So, knowing that it relates to bonding and this mole connection, let's take a look at some questions that will revolve around colligative properties. Sometimes the questions will be very simple. It's based on the definition. Freezing point depression, boiling point elevation. Sometimes it'll be about the application. You might get a question that mentions about snow on a road and why they add salt to it. That's the connection. Other ones will be very chemistry straightforward. Take a look at the sample question. It says, which solution below would have the highest boiling point? So because it says highest boiling point, I'm looking for the one that is ionic. Now notice, you just can't say it's a solution because all 3 of them are solutions that are all aqueous. So I have to use my knowledge of bonding for this question. So CO2. If you forgot that CO2 is covalent, well, we could take a look. On the periodic table, carbon is on the right, oxygen is on the right. Two right elements coming together are always going to be covalent. So that's not ionic. The second choice, B, MgCl2. If you haven't caught on, you need to look it up. Mg is on the left side. It's a metal, which makes it automatically ionic, but it also has chlorine on the nonmetal side. So that is going to be ionic. Ammonia always tricks students. Students always forget ammonia. Ammonia, NH3. Remember, N and H, if I look it up, N is a nonmetal. And the reason why it's tricky is because H is a nonmetal on the left-hand side. So ammonia is also covalent. So in this question, if I'm looking for the highest boiling point and I need the one that's ionic, well, my answer has to be B, magnesium chloride. Otherwise, it could not be. Notice how easy that was. As long as I know what's ionic and covalent, I can pick out the answer pretty easily. Now, the one thing I want to make note of here is if I change this word to lowest boiling point, well, now it's the opposite of the colligative property. My answer is going to be covalent. Now, when those questions show up, they're also easy to identify because all of your choices would be then ionic except for the one that's covalent. So again, easy question to do as long as you know the procedure. Let's take a look at the last sample question. It says, which solution below would have the lowest freezing point? So lowest freezing point tells me I'm looking for ionic solutes. But notice here, NaCl, Na metal, Cl nonmetal, that one's ionic. Magnesium chloride we just had, that one's ionic. And aluminum hydroxide, Al, is also a metal. So here, all three of these things are ionic. So that must be the mole connection, or numbers of atoms or ions dissolved in solution. So this one, I have to pull them apart. So NaCl is ionic. It has two ions, one Na, one Cl. Magnesium chloride has three ions, being ionic, one Mg, two Cls. And the last choice, C, aluminum hydroxide, actually has four ions, one Al, three OHs, and that's ionic. So here, because they're all ionic, we have to go with the highest number of ions. So my answer has to be choice C. Now again, if I change this word in the question to highest freezing point, it goes against the colligative properties. So then I have to apply it below. That would then be this one, choice 2. So again, colligative properties are an easy concept. A very few chemical things going on, but many places to make silly mistakes. So you have to make sure you understand where the information is to look it up and how the process works. All right, so you may want to watch those examples a couple more times. And now it's time for your worksheet. So as always, if you need to watch the video more than once, go right ahead. And when you're done and ready, complete the worksheet and submit. Take care.